So we started with introduction to classes. Of course, there's lots more to be discussed about classes later on, but for the time being, this is just an introduction. Today, we're also going to have an introduction to a new topic, which is called inheritance. Again, it's just an introduction. We're going to have more than one full chapter later on this topic, but just to get started, so there will be lots of details that we're not going to talk about today, but just to let you know what inheritance is about, and we're going to do an example together. Okay. Now, in the previous set of slides, we were talking about the classes in general. We did an example in class, but there's also another example in the book. What's the example about? There's another example in the slides and in the book, and it's about a bank account. And of course, I expected that you've already studied that. If not, do study it, because it's part of your exams. So in addition to the examples that we do in the class over here, I expect you by default to study the examples that are in the slides at least. Okay, so go back to that example if you did not study it yet, and make sure that you study it and you fully understand it. So it's a full example about a bank class, bank account or something of that sort. In inheritance, we have something called the is-a relationship. So what we are going to be talking about is the following examples. If we have a class called a person, and you have another class called a student, what's the relationship between a student and a person? In object orientation, we say that the relationship is an inheritance relationship, and hence we say that the student is a person. Is a between double quotation, it's known as the inheritance. Can you give another example of two classes that inherit from each other? So a student class is a person, hence we say that the student inherits from the person class. Can you give another similar example? Books and libraries, there is no inheritance relationship. We cannot say that a book is a library. Can you say that a course is a course name? What else? How about library item and book? Can we say that the book is a library item? Then we have inheritance between the two. Okay. Can we say that a car is a vehicle? Then we have an inheritance relationship. Can we say that a faculty is a person, staff is a person, student is a person? A saving account is a bank account. Okay, and this is the example that you have in the slides about saving accounts and bank accounts, which I expect you to study on your own, because we're going to do a different example on our own. Okay, so when we say that student is a person, we refer to the student as the derived class, and we refer to the person as the superclass. We can also refer to the student as the child class, and we can refer to the person as the parent class. So it's either a child-parent relationship or a superclass subclass. Okay, so when we say student is a person, the student is the subclass, is a person, person is the superclass. It's also derived class and superclass. It's also a child and a parent. So we're going to see all those terms as we move on. The important point is that the derived class, in our example, the student, it will inherit all the member functions and variables from the parent class. So if the parent has a member variable which is called name, immediately that will be part of the student class without adding it explicitly to the student class. Okay? And we're going to see lots of examples to illustrate this as we move on. So the example that you have in the slides is about a bank account, and it says that the checking account is a bank account. This is how it's represented. If you want to represent it as something called the class hierarchy diagram, then you have the bank account, and then there's the checking account. We say that is a bank account. The saving account is also is a bank account. So the arrow over here, it shows that this class inherits from the superclass. So again, they refer to this as a superclass, and this as a subclass, this as a parent, this as a child, superclass, derived class, so many different names that you'll become familiar with as we move on. You can also have many levels of inheritance. So in this example, we have two levels of inheritance. CD account, what does CD stands for? Checking account, but this is also a checking account. Let's only focus on this level, but just to let you know that you can have many levels of inheritance. So you can have a superclass, a derived class, another derived class from the derived class, and so forth. So you can have many levels of inheritance. It doesn't stop at two classes only. Yes.
So we can say that money market account is a bank account?
money market account is a bank account. Now if you have a subclass and we say that this subclass money market account is a checking account and the checking account is a bank account, you can arrive to the conclusion that the money market account is a bank account. That's correct. So as you can see, the is a relationship, whenever you have the is a relationship, it means that you have inheritance between those two classes. Okay, so again they refer to them as the derived class or the child class, the super class or the parent class. So, how do you do inheritance in terms of C++ syntax? If you have the saving account and you know that saving account is a bank account, this is the syntax that you use to indicate that you have inheritance. So the first part we are familiar with. We know that we can have the class keyword followed by the name of our class. We're familiar with this. If you want to do inheritance, this is where you start from. So this is where the inheritance syntax starts from. So this says that the saving account, it inherits from the another class which is called the bank account class. Of course, the bank account class, it has to be declared somewhere else inside your program. Okay. Now, why is it preceded by public? This is called public inheritance. Later on, we're going to introduce something called private inheritance and protected inheritance. But for the time being, this is what we have, public inheritance. So for the time being, this is the syntax. It starts from this point, and this is where it ends. So the colon followed by the public, followed by the name of the superclass that you want to inherit from. Yes, Jed?
No, just
so let's do an example now to fully understand this. So now this is the superclass which is called the person class. And in this person class, so there's no inheritance yet. So this is just business as usual. This is what we did last time. So we have a class called person. This person has a name and an address. And then we have all the set and get methods. So set name, set address, get name, get address. So just the typical stuff. Now we also have the print function. And you can pass it cout, just like what you did in the lab. And you can print out the name and the address. We also have another two functions over here. They have the same name as this class. What did we call those functions? Constructors. And we know that in constructors we can use this notation. And this notation, it's optional. You don't have to do it. But this is referred to as the initialization section. Okay. So can we make do without the initialization section? Yes, by all means. So you can, if you wish, do this. And just simply say that name is equal to person. I think it was initialized to person. And address was initialized to. So just some default values. You can do it this way if you want to skip the initialization section, but you have to know what the initialization section is and how to deal with it. So those two are exactly the same. So we have a default constructor. Default constructor, it's going to initialize the name to person, it's going to initialize the address to address. You can initialize it to an empty string if you wish, that's also fine. So you can do this if you want. Okay, and we have another constructor. This is a non-default constructor. How do you distinguish between a default constructor and a non-default constructor? What's the difference between the two?
It has the same name, the default constructor and the same name as the class itself.
This is not the difference, no. Both of them, they have the same name as the class. What's the difference between a default constructor and a non-default constructor? Okay, the default constructor, let's be more specific, the default constructor does not receive any parameters, does not receive any arguments. When you call it without arguments. Okay. On the other hand, the non-default constructor, you need to pass it arguments. So it's always a good idea, as we mentioned, that whenever you create a class, you have a default constructor and a non-default constructor. You can have a class without constructors, but this is not a good practice in object orientation. So there's the default constructor and the non-default constructor. Okay. Again, we're using the initialization section over here, although we don't have to, so we can just simply inside the double brackets, the curly brackets say that name is equal to n and the address is equal to a. That would also work. Now in the main, we're just simply declaring an object of type person p1, right? Is there any function to be called at this point? Is there any function to be called at this point? Say again? Did we call set name? So why would it be called? The constructor, right? Which default? What the default constructor? That's correct. At this point, the default constructor will be called automatically. Okay. This is a repetition of what we did last time. We did not start with inheritance. So do I have to do this to call the default constructor? No. The default constructor is called automatically. But what if I wanted to call the non-default constructor? How can I call it? Yes. So now we can say that this guy is called person 1 and he lives at address 1. Now which constructor will be called? The non-default constructor. Okay. So now as is, yes, there is a function call, and the function call which is done automatically is the default constructor, and the person and the address will be initialized as such. So how can we make sure that this is the case? Well, we can just simply print out. We can call the print function pass it cout. So now the name and the address will be printed out to cout. Of course, later on we can replace this cout with our own file handler. So instead of printing to cout, it will be printing to our own text file. Okay, so let's compile and run. Start without debugging. So we just created a person and we're printing out that person. So the name is equal to person and the address is equal to address, right? Because this is the print function, and the default constructor initialized the name to person, and the default constructor initialized the address to address. Okay? So as we expected, no surprises. So now let's start with inheritance. Let's have another class now, which is called class. We can do it on top of main. So let's have class student. Okay. Now we mentioned it's a good practice to name all your classes with uppercase. Classes and structures, usually they are named with uppercase. Now we want to identify or mention in the syntax, if you wish, that this student class inherits from the person class. So the syntax is public and the name of the superclass. So now we have inheritance. We have the student class is a person. So we have the is a relationship and we have inheritance. Now for the student class we can have our own attributes and functions. Now notice that we don't need to add the name because the name is already inherited from person. We don't need to add the address because the address is already inherited from person. And we'll understand this in a minute. So we need only to add attributes that are specific to the student, not to the person. Can you think of such attributes? ID. Major, let's just call it major. Let's keep it as simple as this. So now those additional two attributes are specific to the student. So now you understand that when you say that we have an is a relationship, it's as if the student is a superset of the person. So everything in the person is also in the student, but not the other way around. So inside the person we have the name and we have the address, and inside the student we take this one step further and we say that the student will also contain the ID and the major. Will also contain, which means that the address and the name are already there. So now the student has four attributes: name, address, those are inherited from the superclass, and it also added to its own subclass the ID and the major. Yes?
Can the function from the student class access private members of the base class?
We'll come to that. And now let's have some public methods. So those are the usual stuff, set and get methods. So for the set we need void set ID and we pass it string ID. And we can just simply over here say that, let's just call it or ID as you wish. And we can say that ID is equal to ID. And I notice that if it's a short implementation, you don't have to implement the class, you don't have to implement the function outside the class. If it's a short implementation, you can just directly implement it inside the class itself. So usually the set and get methods, you can just implement them inside the class. And we have set major, and we're going to pass it string major, and we're just going to say that major is equal to m, and then we need a string get ID, and this will return ID, and we need string get major, and this will return the major. Okay. Now we also need the print function, just like what we did with the super class. We also need the print function over here. So I'm going to call it void print. Now for the time being, I'm going to give it a different name. So I'm going to call it print student. And later on, I'm going to use the same name as the super class. Okay, so print student. It doesn't receive any argument. What does it do? When we print student now, what do we want to print out? When we print the information about the student, what do we want to print out? Salman. Name, address, but those they come from the super class, and ID and major. How can we print the name and the address? We can call the function which is called print from the super class, and this will print out the name and the address, right? So I'm going to start by calling print from the super class, and then I'm going to print out, and this receives the output stream as well, and then I'm going to out the ID and the major. Backslash n. Let's pause for a minute at this point. Print, it receives an argument which is out. We just pass it out as is. Right? It receives one argument, so this is the argument. Let's pause 1 minute at this function call over here when we say print. This is the class called student, and the class which is called student does not have a function called print, right? So what C++ will do, it will say, fine, since the student does not have a function called print, I'm going to search in the parent of student. So it will search in the parent of student, and it will find that there is a function called print, and it will call that function. If it does not find it in the parent of the student, what will it do? If this is a chain of inheritance, it will search in the parent of the parent, and it will search in all the ancestors. So if you have many levels of inheritance, it will search for the print function in all levels of inheritance until it finds that method. And when we started with the slides a minute ago, we mentioned that in inheritance, let's go back to the first slide, it will make more sense to you now. A derived class, like the student class, inherits the member functions, in our case the print function, the example that we're looking at, and the variables, in our case the name and the major, the name and the address. So those attributes and those functions, they're also inherited by the subclass, which means that the subclass is now allowed to call all the functions of the superclass directly. Okay? But now there is one exception, which is the following. Instead of calling the print function of the superclass, can we just simply do this? We inherited the attributes and the functions, right? We inherited the variables and the functions. But can we directly print out the variables? The answer is no, because those variables, they are declared as private. And the declaration of private is very strict in C++. If it's private, it remains private. So you cannot access them in subclasses. So in subclasses, And since this is a public inheritance, then you can have direct access to the public part of the superclass, but you cannot have direct access to the private attributes of the superclass. So how can we access the attributes of the superclass? You can only access the attributes of the superclass through the functions that are provided by the superclass. So instead of calling or printing out those variables directly, what we can do instead is call any function from the public part that will print out those variables. So private is private. This is strict. They are not accessible, not even by the child class. Yes.
Because when we said class student, when you created the class, and you're a public person, you change public to private.
We'll talk about that later. There is public inheritance, private inheritance, and protected inheritance. That will come later on.
So now if you use this function, print student, you will only print the ID later or also use the address. How to use the...
This is recorded. You don't have to take photos. I'll make this available on Island. Yes, sir.
So how to call the function in the super class?
We can call it in main. We've already did that, right? p1.print. So what's your question?
I mean, including ID and major. Do you have only to use only one function, which is print student? Or
okay. So now let's address that. So now we're going to have a student S1, and we're also going to print out S1.print. Where is it? Oh, can you see this, guys? S1 dot. The address, where does it come from? From the student or from the parent? From the parent, right? Yet it's you can see it's from the student. However, next to it we have the lock, which means that this is private. Okay? But we have get address. This is available from the parent. It's not private. There's no lock next to it. So we can actually call get address from S1. Okay? But we can also call print from S1. What will this print out? The address and the name only, right? And what will this print out? Everything. Let's pause for a minute now. The function print, is it defined inside the student class? No, it's not. It's defined in the parent, but in inheritance we inherit the functions and the attributes. However, if the attributes are private, we cannot directly access them. We have to access them through the functions. Now we have another function which is called print student. Is this defined inside the student or inside the parent? Inside the students. In both cases, we can directly access them through our student object. But in this case now, what's going to be printed out is only the name and the address. And in this case, what's going to be printed out is the name, address, ID, and major. Okay? And let's have a C out next to it, just for clarity. And let's compile and run. Let me compile and run, and then I'll answer your question. What happened? Debug, start without debugging. So the first function call, it printed out the name and the address. The second function call printed out the name, the address, the ID, and the major. Why are the ID and major empty? Because we don't have a constructor, right? We did not add a constructor. So we have to have a constructor. So let's have a constructor over here. It's called student. And then we can initialize it to ID. You can initialize it to an empty string if you wish. I'm just going to initialize it to ID. And I'm going to initialize the major to major. We'll change it later on to CMP or whatever you wish. So now we have a default constructor. We can also have an undefault constructor, just like what we did previously. So we have now student, and this student over here receives string ID and string major, and in the initialization section we can initialize this to ID and major So now we have a default and a non-default constructor. And I will have to talk about constructors a bit more in a minute in inheritance, but let's just focus on print for the time being. Okay, so now we understand that, again, very important, let's go back to it again. A derived class inherits the member functions and the variables from its parent class without having to rewrite them. Okay? Now let's assume that you said that this is a print function, and the print function, it has to be called a print function regardless. So also insist on calling this print, although the superclass is also called print. So now this function call over here, it will become confusing, right? In fact, which one would it call? The rules in C++, it says the following. When it searches for a declaration, whether for a variable or a function, it's similar. So this is a function call. It's called print. So C++ will search for the declaration of print inside the student class. If it doesn't find it, it will search in the parent. If it doesn't find it, it will search in the ancestor. If it doesn't find it, it will print out an error that you're making a function call and this function does not exist. So now if you look at this scenario, we have a print function. C++ will search for the declaration of this print function inside the student class. Would it find it? So it will call itself again. And then it will call itself again. And then it will call itself again. And this will never end, right? So this is called recursive calls. And it will be a sort of similar to an infinite loop. So there's an infinite sequence of calls that you'll never get out from. So now how can we indicate? The question is, how can we indicate to C++ that this print function that I want to call doesn't come from the student class, but it comes from the parent class? Immediately when you move the mouse over it, can you see that it comes from the student class? Now let's assume, well, it's not an assumption. What we want to do is actually we want to call the print function of the superclass, not the student class. So how can we do that? We can change the name, of course, but this is what we did, right? So what's the point of?
You can say like a person.
Person dot, what else? And we mentioned that when you call a function, you call it from the object name, not from the class name. And we don't want to repeat this anymore. We repeated this enough times, guys. We cannot say this. We call a function from the object, not from the class. If you call it from the class, there's something called static variables and static functions. We'll talk about those later on. For the time being, you can only call a function through the object name, not through the class name. Let's get over this, please. So what we can do instead, we can say, we can use the scope resolution operator. So the scope resolution operator will say that this print function, it belongs to the class person. We did not use the dot notation. It's not the dot notation. This is called this class, this is called the scope resolution operator. Okay? So this says that the print function, it comes from another class which is called person. Now look at it, when you hover the mouse on top of it, what does it say? It knows that it comes from person. Okay? So now C++ will not search for the declaration of print inside student. It will only search for it inside the person class, because we have explicitly mentioned that this print function belongs to this class. Okay, so now we don't have print student anymore. We have, so this is one function called, right? There's no need to call it twice. Now at this point, we can do the following. So say p1 dot print and send it out. Okay, what will be printed at this point? Address and name. Are they initialized? Name is initialized to name, address is initialized to address. What will be printed out at this point? It will start by calling print of the parent. So now print of the parent is called twice. Okay, it will print out the name and the address. It will also print out the ID and the major of the student, and those two are initialized to ID and to major. So now let's compile and run. So as we expected, the first function call will print out the person and the address, the name and the address. The second will print out the name, the address, the ID and the major. We should have inserted space over here, right? So we can just simply do this after the print out of the address. So space. Okay?
So then you only print ID and major?
Print ID and major of the student. But in that case, you have to cancel this function call. This is the only way to do it. Yeah?
So what's the name of this print function then? Without the person?
Without the person?
Yeah, control Z. Yeah. Now remove the person, the collaborator print out. So this function is also called print, the same as the one as in the original one.
Okay. So now the another surprise is about the constructor. Now I'm going to have a breakpoint over here, and we're going to step into the function, and let's see what's happening. Start debugging. How do I step into the function call? Is there a function call at this point? What is being called? The default constructor. How do I step into the function? F11. This is the student, right? It's going to initialize the ID to ID and the major to major. I'm going to step into this F11 again. Where did it send me? To the default constructor of the person. The default constructor of a subclass will automatically call the default constructor of the superclass. The default constructor of the subclass will automatically call the default constructor of the superclass. But why is that the case? Because now the student class, it contains ID and major. It also contains the name and the address, and those, they also have to be initialized. Although they are private and we cannot access them directly, but we can access them indirectly through the function calls. So whenever you initialize a subclass, the superclass is automatically initialized with it. Okay? F10, it will send us back, and F10. So now when you call the student constructor, the default constructor of the superclass is also called automatically. But is this the case also for the non-default constructors? So how can we call the non-default constructor? We can say that we have student 1 over here. So we have student 1, and this guy is in CMP. So now this is a non-default constructor code, right? Okay, so now let's step into it. Start debugging. F11. But what do I do if it sends me to C++ code? I can step out. F11 again. It might do this a number of times, it's okay. I'm sure we can find a solution for it. Okay, so now this is the non-default constructor, right? Okay. Now I'm going to step into the non-default constructor, and let's see what will happen. What do you think will happen? I'm going to step into it. Do you think it will make another function call? But let me narrow down the question a bit. Do you think it will call the default constructor of person or the non-default constructor of person? Hmm? What do you think? If you think default, raise your hand. If you think non-default, raise your hand. Okay. And now the moment of truth. F11. What did it call? The default constructor is also always called. Okay, regardless whether you make the call to the default constructor of student or the non-default constructor of student, the default constructor of the superclass is always called. Okay. Later on, we're going to see when we go into the details of inheritance, if you have more than one level of inheritance, what's the sequence of calling the constructors? Does it start from the constructor of the subclass, and then the superclass, and then the ancestor classes? Does it go in order, or how does it work? We'll learn about that later on. But believe it or not, all the constructors of all the superclasses in the inheritance chain, all of them will be called. Okay? So it's not just the parent, it's also the ancestors. And it's also going to be the same thing later on when we talk about something called the destructor. So just like you have a constructor at the beginning of the class, there's also called the destructor when the object goes out of scope. So if you have pointers, they would automatically be deleted inside the destructor. And when the destructor is called, the destructors of the superclasses will also have a special arrangement. Okay, but for the time being, we only have to worry about the constructor. Yes?
Can we initialize the name and address from the student?
The question is, can we initialize the name and address from the student? We cannot have direct access to the name and the address. We agreed on this, right? We cannot say that name is equal to, this doesn't work. But do you suggest a way around it?
No, I mean inside the main. Like,
so what do you want me to print out? What do you want me to type?
like we use the default constructor for the student.
We did already, S1 and CMP. Then what?
And then we want to initialize it from the name and address.
So what should I type in?
I'm asking.
And I want to try it out. I want to help you. What should I type in? What is it that you want me to try? Give me a question, I'll give you an answer. But that's not what he asked, but I'll come to this point.
I'm asking if we can go to the non-default constructor of the person.
Okay, now you have clear question. Can we call, thank you, Selma. Can we call the non-default constructor of the person through the student? This is your question. But now we understood that by default, only the default constructor is called. Now the question is, can we call the non-default constructor? Hello, we have to do the same trick as we did over here. Okay? So if I want to explicitly call the non-default constructor, then what I'm going to do is the following. I'm going to call from the person class. What's the name of the function that I'm interested in? It's called person. And I'm going to pass it. Now instead of name and address, I'm going to send it. What's your first name, sir?
Kareem.
I'm going to send it Kareem. And Kareem, he lives in Sharjah, I assume. Okay. So now let's see what do we have. Now this is the non-default constructor, and we're making an explicit call to a non-default constructor in the superclass, and we're passing it Kareem and Sharjah. Okay. Right. Now we agreed that whenever you make a function call from the superclass, would it work without this class? Would it work without the scope resolution? This will also work, right? Because this is not confusing for C++. C++ it knows that person is coming from person because there is no name clash inside student. Inside student we don't have any other function that is called person, unlike print. Print we had to explicitly say that it comes from the person class, right? Now person, the name, it's not being replicated, but nonetheless, if you want to be consistent, there is no harm in doing this. Okay, so now you know that this person class belongs to the scope of the this person function, it belongs to the scope of the person class. Okay? So now let's have a breakpoint again and see what will happen. Now we have syntax errors. What are they? Let's see.
We can't again.
So I removed the class resolution operator for the default for the non-default constructor, and it compiled. Start without debugging. Oh, we want to debug. We want to step into it and see what's the sequence of calls. So now F11, step out. F11, step out. Now this is the non-default constructor of the student. I'm going to step inside. And where did it send me to? The non-default constructor, because we made that explicit call, right? Type. And then step out, step in again, step out, step in, step out, step in, and we're done. The default constructor was not called. Did you notice? So if you make an explicit call to a non-default constructor, the default constructor is not called, because the constructor, it needs to be called once. Okay, there is no need to call the constructor twice. So what did we learn up to this point about constructors and inheritance? Is that the constructor of the subclass will call the default constructor of the superclass automatically, unless you make an explicit call to the non-default constructor. We've also learned that when you make a call to the non-default constructor in the subclass, you don't have to precede it with the scope resolution operator. Before I answer your question, let's see what will happen. Is this the same case if we don't use the initialization section? So I'm going to cancel the initialization section, and I'm going to make the calls regular function calls inside the two curly brackets. So the first thing to be called is the constructor of the superclass, non-default constructor. ID is equal to I, and major is equal to M. Does it compile? This will also compile. Okay, of course it does compile. You've noticed that when we move this outside the initialization section, we can no longer do this, because we understand by now that this notation can only be used in initialization, but this is no longer an initialization, so you have to explicitly say that ID is equal to I. So can we do it the other way around in the initialization section? So the question is, can I say ID is equal to ID instead of initializing it? It doesn't work. Okay, so in the initialization section, this will force us to use the initialization notation or the initialization syntax. Okay, but does it compile? If you use the initialization section, this is the only way to initialize. What's the initialization section? As we mentioned last time, it's what goes before the curly brackets, and it's only used in constructors. You can skip it altogether, just like in this case. We skipped it. We did not use the initialization section, right? That's just a shortcut, and it's widely used in C++. Now let's see what will happen. Will this work or not? It has to work because it's consistent with other function calls. So apart from the initialization section, this is a bit of detail that maybe we can make do without. But when we called the non-default constructor in the initialization section, it didn't work with the scope resolution operator. But if you do the function call in a regular way, just like what we did over here, you can always use this class scope operator. Although in this case we don't have to do it because there is no name clash. The name person is not used anywhere else inside the student class. How do I know this? Simply if you just move the mouse on top of it, immediately it knows, C++, it knows that this is coming from the person class, right? If you move it on top of print, even without the class resolution, it will know that this is confusing, right? Now we have confused C++. Where does print come from? The nearest scope, right? The nearest scope in this case is the student. So now this is confusing. If it's confusing, we have to explicitly specify that it's coming from another resolution, which is the class person. So now it's clear to C++ that this is coming from person. Okay? And since this is clear for C++ that it's coming from person, we don't have to precede it with the scope resolution operator, although there is no harm doing it if you want to be consistent. Okay? So one last thing very quickly. If we have a function which is called modify information, I think you understand this by now. Modify, let's call it modify information, and we want to pass it string in U major, so the guy changed the major, and we have string in U address. Okay, and I notice that we are trying to change two things over here. We're trying to change the major, but the major simply comes from the student class, right? But where does the address come from? From the parent class. So the first one, it's simple. We can just simply say that the major now is equal to in U major, right? So this is simple. But we cannot say that the address is equal to new address, because address was private in the superclass. So immediately you'll have a syntax error over here. Can you see the error? It says inaccessible. But why is it inaccessible? Because it's private. So what do you suggest? How can we? Ali? Which function? Get address. Set address. Jad.
Can you use the scope operator?
Even if you use the scope operator. Even if you use the scope operator, it's inaccessible because it's private. Set, Ali, not get? Okay. So what shall I write? Yalla, Ali will help us out. What do you suggest, Ali? Set address. هي هتيجي. This is a function call, Ali, right?
Yeah.
So we open the parentheses, and what do we pass it? The new address. Right? So now we call the set address of the superclass, and we just simply passed it the new address. So now the new address will replace address in the superclass. Right. This function, where does it come from? Person. There is no conflict, right? So we don't have to precede it with the scope operator. However, if you want to be consistent and you want to precede it with the scope operator, there is no harm in doing so.
If address was in the public
then there is no problem at all. We can just simply say address is equal to new address.
or we can use the scope operator.
Yes, but you never do that because we agreed that all the attributes, all the data variables, they're always private and they're only accessible through the function calls. Okay? So I'm going to stop here. This is an introduction to inheritance. We're done with the introduction to inheritance. There are much more details, but those will come later on. Okay? There's an example in the book about the bank account and subclasses. Please do study that as well. If you did not submit your homework, please try to do so as soon as possible. Bring it to my office. Thank you.